Hello, and welcome to a continuation of 1.1 parent functions and transformations. In our last couple videos, we talked about the impact of adding k to the end of your equation. That is going to shift your graph vertically, k units. And then if we change our input, or we have a value added or subtracted to the x directly, that's going to shift your graph horizontally, h units. So here I do see a -1 inside attached directly to the x. Keep in mind that there is a minus in our formula, which means we actually want to do the opposite of what we see here. So this -1 I'm going to think of as a +1. So that is going to be a horizontal shift to the right 1. We are going opposite of that -1, but vertical stays the same. So this is outside, separate from the x, which means it's a vertical movement. Adding and subtracting is a shift, and we keep it the same direction as you would think. So -2 does mean down 2. Number 2, I only have a -4 outside, which means we are only shifting down 4. Number 3, I have a +2 inside, which is going to make this go left 2. The +3 is going to go up 3. The +6 is going to move us to the left 6, and the +1 is going to move us up 1. So just to remind you what this means, if I start with the parent function, I'm going to focus specifically on number 4. The parent function is an absolute value function. So it's a V-shaped graph centered at the origin. To graph my new function, I need to go left 6 and up 1. So I would move left 1, 2, 3, 4, 5, 6, and I would go up 1. My V is now centered here. The shape does not change. It has the same shape that it did originally. It's just in a different place. So that is how the adding and subtracting are going to affect the graphs of your parent functions. We're now going to look at some multiplying. What happens when we multiply? Looking at my first graph, the parent function p of x is absolute value of x. And in my new graph, I have g of x is negative absolute value of x. It's a little bit hard to see, but there is a negative there. Negative absolute value of x. So multiplying that front by a negative just caused your graph to flip down. We call that a reflection. It did go from up to down. Up to down movement is vertical, so this is a vertical reflection. Multiplying by a negative causes your graph to flip from up to down. Here's an absolute value function, and we multiplied by 2 to get g of x. And if you notice, our graph got skinnier. So every y value was multiplied by 2. If I focus on this point right here, x is 1 and y is 1. Well, that graph got multiplied by 2. X is still 1 at this point, but my y value is double. If I focus on this point, my x value is 2 and my y value is 2. My x value doesn't change, but my y value doubles, and now my y value is 4. So we multiplied that y value by 2. Here I have an x value of 3 and a y value of 3, and now I have x is 3 and y is 6. So we didn't change the x value, we just doubled the y value. We're stretching all of those y values. We call this a vertical stretch. And then the factor is 2. We're multiplying everything by 2. In my third example, I have my p of x, that black function. It's an absolute value function centered at the origin. And now my new function, we are multiplying by 1/2. So it's going to be very similar. It's outside, separate from the x, but we are multiplying. So we are multiplying now the y values by 1/2. So instead of 1, 1, We cut that in half, and we have 1 1/2. Here I have 2, 2. The x value doesn't change, but now the y value is only half as big. Here the y value is 3. Now the y value is only about 1 1/2. Here the y value is 4. Now the y value is only 2. So we are multiplying all of the y values by 1/2. Because we're changing the y values, this is something vertical, but it's not a stretch anymore. It is a shrink. Things are getting smaller. And the factor is 1/2. We'll continue looking at these just with parabolas and quadratics. Here's my parent function, x squared. Here we are multiplying that x squared by a negative, and our graph flips over. Again, we call that a vertical reflection. We multiplied the front of our equation. It wasn't inside stuck with the x, it was just multiplied by -1 on the outside, and that made our graph flip down. The second one we've got, x squared, and now we are multiplying the front of that x squared by 7. It's not in parentheses with the exponent. We just took the x squared and we multiplied it by 7. That takes every single one of our y values and multiplies it by 7. So our graph stretches up something like this. Every single one of those points gets multiplied by 7, pulling your graph up so that it is fairly thin. This is again a vertical stretch. And we say it is a vertical stretch by 7 because that's what we're multiplying by. Lastly, I'm multiplying by 1/2. My parent function is x squared. So I take the original x squared function and I multiply every y value by 1/2. This y value was 4 and now it is 2. This y value was 1 and now it's 1/2. So on and so forth for the whole graph. So that red graph is now flattened out, a little bit wider, a little bit flatter than it was before. So this is a vertical shrink by 1/2. So here's our conclusion. If you are multiplying, we've only talked about multiplying the front, the leading coefficient, and your value that you're multiplying by is between 0 and 1. This is going to shrink the graph, f of x, by a factor of a. Because when we multiply by something like, for example, 1/2, our numbers get smaller. That's going to cause our graph to shrink and become smaller. But when we're multiplying by something that's bigger than 1, like 2, 3, 4, we are going to stretch our graph. Our numbers are going to get much larger, and it is going to stretch the graph by a factor of a. When a is less than, this should say less than 0. When a is less than 0, meaning negative, if you're multiplying by anything negative, this is going to reflect the graph of f of x vertically. Or another thing that you might say is over the x-axis. That just means it goes from the top to the bottom. We fold it over the x-axis. So the transformations that I see here in number 1, my parent function is x squared. To get to 2x squared, all we did is we multiplied the front by 2. That multiplying by 2 is going to change vertically. It is not attached with any sort of grouping symbols to the x. It is just thrown onto the front. So this is a vertical stretch by 2. It's a stretch because when I multiply by 2, my values get bigger. Number 2 here, my parent function, y equals absolute value of x, and we are just multiplying the front of that by a -6. This is a vertical change. Now there's two things I want to think about here. The first is the negative. The fact that it's negative is going to be a vertical reflection. That flips your graph from top to bottom. 6, we're multiplying by 6 as well. That is vertical because it's outside. Multiplying by 6 is a stretch because it is bigger than 1. So vertical stretch by 6. So let me show you what this looks like in the graph. My parent function is a V-shaped graph like this. The negative is going to cause the graph to flip down. But negative 6, even more than that, causes our graph not only to flip down, but also to stretch. So it stretches down something like this. And so that red solid graph would more or less be the graph of your new function. Number 3, the only value that I have, we're multiplying by 1/5. It is vertical. But 1/5 is going to cause your numbers to get smaller, so it is a shrink by 1/5. Number 4, you might want to rewrite it to see it a little bit better and pull out the 1/4. This is really 1/4 times the absolute value of x. Or you could simplify it down to the original and work back here. But I think it's a little bit easier this way because we can see that we're multiplying by 1/4. So this would be a vertical shrink by 1/4. All right, go ahead and take a moment, pause the video, and try these 10 examples on your own. Number 1 should be a vertical stretch by a factor of 7. Number 2 is negative, so that's going to be a vertical reflection. That'll flip it down. But then we're also multiplying by 4, which is a vertical stretch by 4. Number 3 would be a vertical stretch by 5. Here we're multiplying by 1/8, so vertical stretch, we're multiplying by 1/8, which means our values decrease or get smaller, so vertical shrink by 1/8. This one, similar to from the last page, you might want to rewrite as 1/2 times the absolute value of x, and it's a little bit easier to see that that 1/2 is a vertical shrink by 1/2. Number 6, the only thing we have is that negative or a -1 in front, so this is going to be a vertical reflection or a reflection over the x-axis. Number 7 is a vertical stretch by 3. Number 8 has 2 parts. Again, we have a vertical reflection. And we're multiplying by 1/4, which does cause our numbers to get smaller, so that would be a vertical shrink by 1/4. Number 9, 1/2, multiplying by 1/2 would cause a vertical shrink by 1/2. And this would be similar to number 5. I can pull out that fraction 1/3, so really I have 1/3 x squared, which would be a vertical shrink by 1/3. Our last couple pages are going to be putting it all together. We have talked about how A will change your graph. So this is going to either stretch, shrink, or reflect your graph. H, adding to the input, is going to be a horizontal shift, either left or right. K, adding to the outside of your equation, is going to be a vertical shift. So in number 1, I've got 3 numbers to work with. I've got a 3 that's multiplying, a 2 that's being subtracted, and a 6. Well, how we go about this is we work our way from the inside out. We're going to follow the order of operations. So I start within any grouping symbols first, inside this x minus 2. So the very first transformation I write is the shift to the right 2. After grouping symbols, we do exponents, but there are none. Multiplication and division. So this 3 is the next number that I work with. The second transformation that we apply is the 3, which would be a vertical stretch by 3. And then the very last thing we do is we deal with that plus 6, which is a vertical shift up 6. So start inside, work your way out. First thing I do here is I'm going to shift to the left 4. Second thing I do is I deal with my multiplication. This is a vertical shrink. We're multiplying by 1/2. So that does make my numbers smaller. Vertical shrink by 1/2. And then last, I have a minus 7. So vertical shift down 7. So I have those in order, 1, 2, 3. Number 3, notice there's nothing in parentheses, no grouping symbols to work inside of. So I just go straight to this one here. Doesn't matter what order we go in, but we need to do a reflection because it's negative. And we need to multiply by 5, which would be a vertical stretch. Then after that, we deal with the addition that's on the outside, which would be a vertical shift up 3. And that is the third transformation we do. Number 4, I work my way inside out, so the first thing I do is move this to the right 1. There's no multiplication, so I just go here. The second thing I do is shift everything down 4. I'll do 1 or 2 for you, and then I'll leave you with the rest. Number 1, I work inside out. The first thing that I do is I shift everything to the right 7. The second thing I do is I multiply my y values by 3. That is a vertical stretch by 3. And then the last thing that I do, third, is I move everything up. That is a vertical shift up 2. Number 2, working inside out, I see a plus 5, means I'm going to shift everything to the left 5. That's the first transformation. And then I deal with my negative, so the second thing that I do is a vertical reflection. All right, go ahead and pause the video and try those next 4 on your own. All right, you can pause the video one more time to check your answers. I did try and put these in order. So step 1, 2, 3, 4. Step 1, 2, 3. Step 1, 2. Step 1, 2, 3, 4. When you do your vertical stretches and shrinks and your reflections, they do not need to go in this order. So you could swap these two, but everything else needs to go in the order I have it. That's going to bring us to the end of our video today. Thanks so much for watching and have a great rest of your day.